Did you know that there are actually two different definitions of one day? It just so happens that for us on the Earth, they're about the same, but on some planets they are completely different. My name is Bryony and I am an astronomer at the Royal Observatory in Greenwich. And today I'm going to explain the difference between a sidereal day and a solar day. Now they work out for us on Earth as about the same length of time, about 24 hours, but there is a difference. A sidereal day is defined as the time it takes for a planet to complete one rotation on its axis, to spin around completely once. Now, that takes about 24 hours on Earth, a little bit less actually. The other definition of a day, a solar day, honestly makes more sense from our point of view. A solar day is defined as the time it takes to complete one full day-night cycle. That is for the sun to rise, then set, and then rise again. Now, like I said, on Earth, they're about the same, 24 hours, give or take 4 minutes. But on some planets, they are completely different. For example, on the planet Venus, it takes 243 days to complete one rotation. And yes, I did say 243 Earth days. But that doesn't mean that you're going to have to wait 243 days to see another sunrise. Because of the way Venus orbits the sun, it actually only takes 116 Earth days to complete one Venusian solar day. So you only have to wait another 116 days to see the next sunrise if you're holidaying on Venus.
Hi, I'm Dr. Greg Brown, one of the astronomers here at the Royal Observatory, Greenwich, and today I'd like to try to answer the question, why, when we look for life in the rest of the universe, do we only seem to look for life like us? When I say like us, I don't just mean humans. I mean life found anywhere on the surface of our planet. When we look for life out in the rest of the universe, we're always looking for a habitable planet, a planet similar to our own Earth. And yet life on Earth is very diverse. It ranges from single-celled organisms all the way up to the giant mammals of the sea. Through plants and fungi, life is very weird. Some of it doesn't even seem to follow the same sort of rules as the rest of it. The most obvious and topical example being viruses, which share some but not all of the same characteristics of other types of life on Earth. So if life on Earth can be so diverse, why couldn't life out in the rest of the universe be even more diverse? Well, it could, possibly, maybe, but we don't know, and that's rather the point. We have only one example of how life can definitely exist in the universe. This one. And that means that it's by far the easiest type of life to look for out in the rest of the universe, even if it's only because we know what to look for. We know what type of environment it likes to live in. We know what effect it has on that environment, which means that we can study distant exoplanets, look for those same signatures, and try to prove whether life actually exists out there. So there you have it. We look for life like us, simply because we wouldn't know what to look for otherwise, and because we're following the only example that we actually have. Us.
Astronauts on board the International Space Station are currently whizzing around the Earth at an astonishing 17,500 miles per hour and completing one orbit of the Earth every 90 minutes. But how far is the station from the Earth? How many astronauts are on board it? And can we spot it from the ground? I'm Patricia and I'm one of the astronomers working at the Royal Observatory Greenwich, and today we are talking about the International Space Station, otherwise known as the ISS. About the length of a football field, the ISS is not just an astronaut's home in space. It also serves as a unique science laboratory and allows astronauts to conduct research and experiments in a microgravity environment. At any given time, you'll find somewhere between 3 to 6 astronauts living and working on the ISS, and those astronauts will spend around 6 months on the station. But sometimes an astronaut will spend a bit longer than that, like NASA astronaut Scott Kelly, who stayed on board the ISS for almost a year. You might be surprised to hear, though, that the ISS is not that far from the Earth. In fact, it's only around 250 miles above the surface of the Earth. It's also easy to spot too. You just need to know when and where to look. Head to NASA's Spot the Station website, enter in your location information, and the website will tell you when the ISS will fly over, the time of the flyover, and the direction in which you need to look.
Hello, my name is Tanya, and I'm one of the astronomers at the Royal Observatory, Greenwich. All the stars in our sky belong to our galaxy, the Milky Way, and it's home to anywhere between 100 to 400 billion stars. But how many stars can we see with our eyes? Well, that depends on lots of factors like the visibility conditions at your location, your eyesight, your age, and the brightness of a star. Counting all the stars in the sky would be something very difficult to do, but we can try to establish the number of potentially visible stars by thinking about how faint an object can be before we stop seeing it. So astronomers use something called apparent magnitude to measure how bright a star appears in the sky, and it's generally considered that anything above 6.5 will be invisible to us. So that means that a star must have enough intrinsic brightness so that after its light has traveled through the vastness of space to reach us, it will still measure an apparent magnitude of 6.5 or below. So that means a lower number, a brighter star. Take Proxima Centauri, for example. It's 4.2 light years away, so it's the closest star to us, but it's a cool red dwarf star, so it measures an apparent magnitude of 11.13, too faint for our eyes to detect. By comparison, the hot blue supergiant Rigel is 860 light years away, but is one of the brightest stars in the sky with an apparent magnitude of 0.13 on average. Since we do know how many stars there are in the night sky that measure an apparent magnitude of 6.5 or below, we can have a rough estimate of about 10,000 stars that you could see in both northern and southern hemispheres. From London, we could expect about half of that theoretically, not at the same time because some stars will set as others rise. However, with light pollution, we would expect at most a few dozen stars on the clearest of nights. That's all from me today, here from Observatory Online. Thank you for joining.